Hello everyone, welcome to my programming club. Today we will be solving another daily lead code problem, and the problem's name is merge in between linked list. Okay, so let me describe this problem statement in my own words. And so what you will be given is you will be given two linked lists. Okay, and both of them will be singly linked list. Okay, and let's say this is the linked list, first linked list that is given to you. Okay, then you will be it is, and the indexing in this particular linked list will be 0 based. Okay, so 0 1 2 3 4 5, and values can be anything: a, b, c, d, e and f. Okay, this is null. So you will be told that you will be also provided two indices. Let's say we are being provided in index first index as a, or let's say not a, since we have already taken it in as value. So let's say first index is index 1, or left and right, you can say. Left is, let's say, 2, and then right is, let's say, 3. Okay, so you are told that you have to remove all the indices between left and right, including left and right. Okay, so you have to remove this particular part, and you will be given another list. Let's say there is another list that is given to you. Let's say this is the list that is given to you. Okay, G, H and I. Okay, and this is null. Okay, so this is another list that will be given. So you have to insert this list, take this list and insert it in place of this portion that you have removed. So the modified list should be looking something like this: a, then b, then comes your g, and then comes your h, and then comes your I, and then it will be e, and then it will be f. So you have to, remove, you just removed, c and d, and instead of that you inserted this portion. Okay, c and d is gone, and this portion is inserted in the first list. So you should be inserting this portion here. So this is what you have to do, and you have to return the head of this modified linked list. Okay, return head. So let's see how we can do that, and let's have a look at the constraints also. So if you want, I can read problem statement for you. Like, you are given to linked list 1 and linked list 2. Okay, of sizes n and m respectively. List 1's node from ath node to bth node, you have to remove them and put list 2 in their place. Okay, so this is also shown pictorially also. Okay, that this is the list 1 that will be given you, and then this is the list 2. So you have to remove from ath node to bth node, including ath node and bth node, and you have to add this particular list. So if you observe this, carefully, this picture itself is giving us enough hint, how to achieve this. Okay, let's say this is the first list that is given to you, list 1, and this is the list 2. So you have to just break this link, okay, break these two links, and instead of that you have to make a minus 1th node to point to the head of the first list, and tail of the head of the second list. Okay, a minus 1th node of the first list will be pointing to head of second list, and tail of second list, tail of list 2 will be pointing to the b plus 1th node of first list. Okay, and you just have to break these pointers. Okay, so I guess it is a linear order traversal here. So what we will be doing is we will have a variable index initially set with 0. We will continue, traversing this particular list till we reach at this particular node. Okay, a minus 1th node. So let's say you are also having a variable current node, and initially it will be set with the head of first list. Okay, then this current node will keep upon moving starting from here till it reaches this particular node, and then you will get the address of the, let's call it front. Okay, front node. So anyways, we need four addresses of 4 nodes. This particular front node, this particular node, let's say this is the rear node, and head node is already given to you for second list. We have to just find out the tail. Okay, so these 4 addresses when you will be having, you will be able to just change their links. Okay, so you can continue this moving this current node. Current node will be equal to current node dot next. Okay, till you reach a minus 1th index. Okay, this way you will get the front node, and then once you have this, you will then keep moving your current node further till your index reaches b plus 1th node. Okay, and then you will be having your rear node value. And for the list 2, it is very easy. For the head part, you are already given. You have to just find out the tail. Similarly, similar thing you can do for list 2. Okay, your tail of list 2 can be started from the head, and it will keep moving just like we were moving this current node till you reach a node whose next is null. Okay, that will be the tail of that second list. And once you are having that, what you will do, front node dot next, or in C++ today we are implementing, so front node next will be nothing but head node of list 2. Okay, and tail of list 2 next of this node will be nothing but rear node. Okay, so this link we are forming here, and this link we formed earlier. Okay, this link is formed in this particular part. Okay, and this particular link is being formed in the part below. Okay, this part. So I hope you are able to understand the approach, and let's have a look at the implementation. So first of all, we will be finding our front node. For that, we will be initializing our current node with the head of the linked list 1, and then we will be having a variable index which will be helping us to arrive at a minus 1th node. You will continue moving your current node in from left to right direction till your index reaches a minus 1th node. Okay, once you are having the address of a minus 1th node, you will store it in front, and then you will continue moving your current node again till index reaches b minus 1th node. Okay, once you are having that, you will store it in a variable. It is just for the sake of your understanding, and then it will be stored in the variable rear. Okay, so then you will be having two other variables. One will be storing the head of list 2, which is by the way given to you as list 2, so second list head, and one variable will be second list tail. Okay, so you just have to find out the second list tail's correct position. So you will be moving second list tail variable across the second list from left to right direction till it reaches a node whose next is null. Okay, so we have to find out this node, and your tail of list 2 is starting from here. It will keep moving in this direction, okay, till it reaches the very last node. Now you will be having all the indices after this particular loop terminates. Okay, and once you are having all the addresses, you will change the next pointer of front to the second list head, and this is this operation that we are doing here, forming this link. And for the second operation, we are forming the second link. What is the second link? Let me change color here. So this was the first operation, and this is the second operation. Okay, and then we will be simply returning head of first list. Okay, so that is how we will be solving this particular problem. If you are still having any doubts or any queries in general, then please feel free to ask them in the comment section. And as far as time and space complexities are concerned, let me analyze them for you. Time and space complexity, let's say as you can see, we are traversing both linked lists, so you can take time complexity of order n plus m, where n plus m are the sizes of two lists, because to find the tail of second list, you have to traverse the entire list here in this particular loop, so that's why entire length will be used up almost. Okay, and these indices a and b that you will be told to remove the section in between, including them, are varying from the first index to the one less than the last index. Okay, so it can be also taken as order of length of the first list. So this is length of, let's say, list 1, and this is length of list 2. Okay, and space complexity wise, since we are just playing with the links, so we are not using any extra space. It is just order of n, order of 1 constant. Okay, so these are the complexities, and this is the approach. Okay, thank you for watching. Have a great day ahead.